15:35. Okay. Okay, Bu Fatina, you can play the video again. Okay, let's begin. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for all participants and panelists. Thank you for all your presence. Let me introduce myself first. My name is Divya, and I will be your master of ceremony today. It's such an honor to welcome you here in this event. The Honorable Dr. Paolo Beccarelli, Dr. Andry Widyowijatnoko, and Dr. Andhang Trihamdani as today's speaker. The Honorable Dr.Eng Donny Koerniawan, today's moderator, and also the Honorable Dr. Robi Duiko, the chairman of the committee, the Honorable Dr. Sri Mariati, Dean of School of Architecture, Planning and Policy Development, ITB, and all beloved participants. Let me begin by giving you a warm welcome to the third webinar series, Road to HABITechno. Before we come to the main session, here is a brief description about HABITechno5. HABITechno5 is a biennial international conference focusing on innovative solution in concept and practice of contemporary technology for housing and settlement development. HABITechno5 International Conference will be held on November 11, 2021 online with the main theme Adaptive Technology for Resilient Human Settlement. As a pre-event, we are conducting a webinar series towards the main conference. Today's webinar topic is Adaptive Material and Technology. This is time breakdown for our event today. The first speaker will be start presenting at 3:50. Each speaker has 20 minutes time slot and followed by 30 minutes Q&A session in the end. Next, please, Pak Fauzan. This is the rundown for event today. Hopefully, we'll finish at around 5:30 Indonesian time. To make our time conducive, here's the rule of the day webinar. Please, next, Pak Fauzan. Participants are required to use a Zoom account based on their registered name. Participants are expected to be disciplined during the webinar session, and participants must understand and comply with the procedure for question and answer as follows. Participants can ask questions only through the chat feature on the Zoom platform of the live chat feature on YouTube streaming. In order to avoid repeated question, a participant should read the existing question before asking. Participant can only ask substantive questions related to the webinar theme. The organizing committee has the right to exclude participants who do not follow the rules. Next, please. And we also have door prizes. We have 2 books from Pak Donny Koerniawan as moderator, and also 2 books from YKKIP from Dr. Andhang as speakers. And also you can register your email through this link. E-certificate is available for you, and we do not have any attendance list. Okay. Before this, sorry, Pak Fauzan, can you come back to the rundown? For the first agenda, we invite Dr. Robi, the chairman of the committee, to give an opening speech. Mr. Robi, time is yours, please.
Thank you, Pak Divya. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good afternoon for Indonesian participants, and good day for participants who are not only coming from other countries, but also on behalf of universities, consultants, and governments. Now we almost have about 140 attendees for the seminar. Ladies and gentlemen, I, as the chairman of this seminar, on behalf of the committee, to all participants and three speakers, Honorable Dr. Paolo Beccarelli from University of Nottingham, thank you for coming, Dr. Paolo, Dr. Andry Widyowijatnoko from SAPPD ITB, Dr. Andry, thank you, and Dr. Andhang Trihamdani from YKKAP R&D Center Indonesia. Thank you, Dr. Andhang. And also our moderator, Dr. Donny Koerniawan from SAPPD ITB. Thank you, Pak Donny. I appreciate for your participant to contribute in this third webinar series of 5th HABITechno seminar in 2021. And also to Dr. Sri Mariati as our Dean SAPPD ITB, thank you for supporting us. This might be the best occasion for all of us to be able organizing this event, even though by virtual meet conference due to pandemic. Ladies and gentlemen, and all participants, also speakers, today is the 5th HABITechno and become the 5th 2 years has been held until now. It means it has been running for 10 years. Alhamdulillah, adaptive technology for resilient human settlement to be a main topic seminar that based on sustainable competitiveness, networking, and community to be achieved as mentioned by Mr. Divya. This topic has two main thematic areas as an adaptive technology and resilient human settlement. Both are addressed to the basis of choice for participants to submit of extended abstract on September 1st, as presented at the beginning. Anyway, that we have 3 webinar series for you to attend as an introduction that may completely understood towards main seminar that presented by many invited speakers. Hopefully, based on this webinar series, may convey you to provide a completely understanding on the 5th HABITechno seminar on November 11th, and also full paper submission on December 5th at the end of this year. So enjoy this webinar series, and until we meet again in the HABITechno5 seminar. Keep healthy and stay safe. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Robi, for your speech. Next, we invite Dr. Sri Mariati, the Dean from School of Architecture, Planning and Policy Development ITB, to officially open the webinar series today. Time is yours, Ibu Sri.
Thank you, Pak Divya. Distinguished Program Coordinator of Architecture Postgraduate Program, Ibu Dewi Larasati, distinguished all of the speakers and participants of the third series webinar, Go to the 5th HABITechno. Good morning, good afternoon, good evening. Warmest greeting from Bandung, Indonesia. HABITechno International Conference is a biennial conference managed by the Architecture Study Program at the School of Architecture Planning and Policy Development, Institut Teknologi Bandung. Our webinar today is a part of the 5th HABITechno International Conference. It is the third series. And the topic of our webinar today is the adaptive material and technology. Today, we are honored to host 3 prominent lecturers delivering their lecture, and each of them has expertise and experiences that are worth and valuable to be shared to the participants. On behalf of the School of Architecture Planning and Policy Development of Institut Teknologi Bandung, I would like to express our sincere gratitude to all invited lecturers, Dr. Paolo Beccarelli. Thank you very much. Dr. Andry Widyowijatnoko, thank you, Pak Andry. Dr. Andhang Trihamdani, thank you. And also we have here the moderator, Dr. Donny Koerniawan. Thank you, Pak Donny. And I would like also to send our gratitude to the organizing committee, Pak Robi and team. Thank you very much. It is hoped that the webinar today could be a space to enrich knowledge and experience in construction industry. So hereby I open the third series of webinar to the road to the fifth HABITechno. Thank you very much.
Thank you, Ibu Sri. And that remarks the official opening of webinar series today, Road to HABITechno5. We finally arrived to the main session. The session will be guided by Dr. Donny Koerniawan. But before that, let me quickly introduce Dr. Donny first. Mr. Fauzan. Okay. Pak Donny Koerniawan gained his bachelor and master degree from ITB and took his PhD in University of Kitakyushu, Japan. And this is some of grant and awards that Pak Donny has already achieved so far, and a lot of research grant and also paper and journals. Okay, without any further ado, Pak Donny, I'll hand this over to you as moderator today. Please, Pak Donny.
Thank you very much, Pak Dibya. Thank you very much, Deans of Schools, Architecture and Planning and Policy Development, Bu Sri Mariati, and thank you very much to Pak Robi as the chairman of HABITechno for the fifth, and thank you for the participants that coming today in the webinar series Road to HABITechno Seminar International of the Fifth. Okay, before we are going to the main sessions of this webinar series, I would like to share to you to encourage you to submit your papers in webinar in the seminars of. So, would you please to the committee let me to share our screens? Okay, I would like to introduce you. If don't hesitate to submit your papers in the HABITechno. So, if you don't know about what is HABITechno, you can go to the website of HABITechno. So the fifth HABITechno International Conference themes today is about adaptive technology for resilient human settlement, and there is so many subtopics. So everyone who wants to write a paper, don't hesitate to submit your paper. And the important things that the HABITechno this year will be published in the Scopus Index Proceedings, and there is two journals. Selected paper will be published in the two Q3 of journal. So don't hesitate and don't be shy to submit your paper in this conference. Okay, for the participants. And today we have three distinguished presenters that our topics today is about adaptive technology and materials. So without any further ado, I want to introduce you for the first presenters of webinar series today. We have Dr. Paolo Beccarelli. And right now, he is an assistant professor in the University of Nottingham and originally from Italy, and a graduate from master program in architectural engineering and PhD on architectural fabrics and foils from the University of Nottingham. And so many experience. One is the important things, what this experience is about the charters, engineers, and architects in Italy. and right now he is a vice chair of the European network Transinet, and so many selected publications that you can read in the share screens. If you want to have the papers of Dr. Paolo Beccarelli, so you can send by email. Is it okay, Paolo?
Absolutely fine. Yes, of course. Yeah.
And one important thing that Dr. Paolo expertise is his research is about focus on the impact of the new digital tools on the designs, engineerings, and the manufacturings of temporary lightweight structures, and develop innovative designs that approach and form findings techniques to make possible complex projects based on architectural coated fabrics. So this is yours currently research right now, yeah, about ETVE.
Exactly.
Okay,
And today we're going to see some examples of that.
I think it's a pleasure to know about your experience in the research of the new materials. So time is yours, Paolo, and you have 20 minutes, and I will tell you 3 minutes before ends. Thank you. Time is yours.
Yeah, thank you. Thanks again for inviting me. I think it is a pleasure to be here today to share with you some experience. We selected a project from our recent pavilions that we designed with some other colleagues for one of the international competition for the Expo Dubai. And we are seeing today basically how materials can really be used in an interesting way, basically to achieve transformable and transportable structures in an effective and creative way. So I'm going to start sharing my screen. So I think that you should be able to see my screen pretty soon. Give me a second. Here we are. So you should be able to see my screen, and then now I'm going to move full screen. So here we are. Let me see if I can remove the top bar here. So now, yeah, it's on the side. Excellent. Good. So here we are. So we selected, as I mentioned, an interesting pavilion that we designed a few months ago, basically last year. And here we're going to talk about the design process and the construction process of this Corolla pavilion. First, I'm going to start sharing with you a bit of my expertise. As the moderator already mentioned, I'm assistant professor in architectural structures at the University of Nottingham and co-founder of a couple of startups companies based in Europe, so Maco Technology and Tenserity Solutions. And today we're going to see a project developed with the Maco Technology, one of these two. Few information about the University of Nottingham, a pretty large institution with quite a few students. We are talking about 44,000 students every year enrolled in our campuses, and we have 4 campuses in UK, 1 in Malaysia, and 1 in China. This is a picture of our UK main campus in Nottingham. About myself, so I started as a architecture engineer, so that means something between architecture and engineering. I really like this field just because you can experiment with new materials and structures in a creative way, but at the same time be sure that the structural performance are always assessed and validated properly before you go into production. And these are some examples of structures that we do. As you can see, there are always a lot of membranes. That is my key topics. We work with coated fabrics. We work with ETFE in single layers projects or double layers, inflatable structures, but all of them are generally pretty temporary. So they're not permanent, or if they are permanent, they're generally designed for a certain specific lifespan. Okay, and as I mentioned today, we're going to see a few interesting things about the advantages of soft actuators. So basically, actuators based on fabrics and pneumatic system, of course. We're going to see the idea of an interesting weather-responsive co-working pod. We're going to see the design of this pod, which is called the Corolla Pavilion. and we're going to see the construction process. Very interesting to see how the materials are used, and we're going to see finally the results achieved, the conclusions, with a nice video presenting the key functions of the pavilion. So let's start with a short introduction about soft actuators. I don't know if you are familiar with this concept, but basically the idea is that you use a soft material, like in this case, you inflate the element and you can use the pressure inside the chambers to achieve an interesting effect where you basically change the shape of your element. You can achieve a certain movements in one direction or in the other direction. It really depends in which direction, in which cells you push there, basically under pressure. And that was basically the initial concept designed by one of the designers involved in these projects. And then, of course, we engineered that concept several times. And the final version, you will see the pictures, is basically based on a translucent polyurethane multi-layer membrane with a fabric inside and a polyurethane coating. And of course, we manufacture that with a custom welding pattern and cutting pattern as well. Okay, so let's start from the idea of designing a weather-responsive co-working pod. So why did we start with this? Well, Ophir, one of the designers, had some interesting ideas that he experimented and investigated during the master dissertation. And the idea was, of course, to use air, like in this case, to inflate one flexible element and to achieve movement with that. As you can see, when you have a flat element, like in this case, you change the pressure in one of the two sides, like in this case, you can achieve a certain movement and a certain bending, basically in one direction, like here, or downwards or upwards. It really depends where you put the inflated air, basically the pressure of your system. The concept is that you shrink the membrane on one side, and the skin basically is going to bend because of that additional pressure that you generated. And here is basically how you move from a concept phase into something much bigger and with a proper function in an architectural project. So this is basically one of the components that you're going to see for the pavilions. And of course, the idea is not only to achieve movement in a clever way, is also to use light sensors to measure how much light you have, or temperature sensor to measure the temperature on site, inside and outside the pavilion. You can also measure the rain and the proximity in case there are some people interacting with the pavilions. All these inputs are then controlled by a microcontroller, generally based on Arduino, Raspberry Pi, especially in the pilot projects, let's say. And then, of course, we control through the microcontroller the air pumps, the valves, and the actuators. The first opportunity that we had to experiment this was a competition for Dubai 2020. So the local government here in Italy decided to sponsor a prize to design and build a prototype to basically show on site during the Expo Dubai 2020. And we basically decided to submit this idea as an entry for the competition. And we actually got one of the prizes. We got the funds to develop and build our idea, basically, or actually the idea of the three designers built in that. My role was mainly as a technical manager. So basically I transformed their architectural idea into something buildable, in something that was structurally safe and feasible, let's say, with the budget that was available. And here you see a final short description of the pavilion. As I mentioned, is a weather responsive. So it's basically designed to interact with the weather with sensor and to adapt the shape according to that. And is originally designed to be a co-working pod. So basically a space that you share with people where you basically connect your devices with Wi-Fi, with electricity, and you basically work in a pretty nice environment protected from the weather. And this is basically the concept that we submitted for the competition. So a pavilion that is, in case of rain or cold temperature, is basically closed and is protected from the weather, and that you can open this shelter in a dynamic way. You can use one element as a door, basically, for the element, or you can even open the entire envelope in a pretty elegant Corolla-like, let's say, like a flower, basically, shape. Very elegant, but at the same time, pretty effective as well. And it has been quite a long process. It took like 1 year to transform the initial idea in something buildable. But the idea was really to achieve something like this. So as you mentioned, as you see here, this was the space originally allocated for the pavilion. And the idea was to build a nice space here, which is then protected in case of sun or in case of weather, is basically protected by these pneumatic actuators, which are actuated by something hidden down here in the basement of the pavilion. And the idea is that when the rain comes, like in this case, then the envelope is going to close and provide a waterproof, air-conditioned space where you can stay. This is a picture of the inside, where you basically have your nice envelope protecting you, and then you have your working station here, giving you the space that you need to work on with your computer or your laptop or your smartphone. Let's see a bit the design process of this. So we started with a pretty interesting and ambitious agenda here. So the idea was to have, of course, a pretty clever system. So all the sensors are generally here on the roof. So there is where we have all the sensors able to measure the wind speed, for example, the temperature, the rain, and so on. And then we have, let's say, the core of our system is hidden inside here. So that is basically the brain of our system, where we have the microcontroller, the pumps, and all the tubes that are then feeding the different basically leaves of our plant, our pavilion. And then here you see all the different components integrated into this idea. A bit more in detail, as I mentioned, there is a top ceiling cap here, which is the one protecting the basically all the sensors that are generally positioned in this place. Then we have the rigidity support for the flexible actuators, and then we have here basically the column support in this cantilevered element with the core of our pavilion, the inflatable units, and then we have the desk, which is also cladded with flexible fabric. And this is the pavilion in plan. So when it's closed, it's a pretty compact element. So we talk about 3.5 meters in diameter. And then, of course, it becomes much bigger, providing extra protection for the external part of the pavilion as well. So here you see when it's closed, scheme and the section was done, of course, in this position looking down. Similar concept for the section. So here is the section line looking in this direction, and here you see the two key positions. One is fully closed, like in this case, with the skin basically folded down, and then here when the skin is folded up. But as I mentioned, all this movement is achieved in a pretty clever way, basically with a printed pattern on the welding lines, and then the pressure up there, which is coming from some tubes here. You will see them in the pictures, and is basically they are basically connected down to the inflatable units, which are hidden down there. And when you change the pressure, as in the initial concept, these elements are able to bend upwards. Otherwise, when they are closed, they bend downwards in this case. Okay, let's have a look to the construction process. So, of course, the best way here is always my recommendation for students is to start with an easy object that you can control in size. You don't invest too much time and money in that, but you really understand what's going on. So these small one-to-one scale mockups are very useful to show you if your idea is working. So it's always a good starting point, as that is what we did together with the three designers. We started with this pattern. You can see with a pretty simple welding line in this direction. And then by inflating this, you achieve this curling, curled shape. And this is the valve, as you can see. It's a quite interesting shape, but at the same time, we were not totally happy and convinced by the force. I mean, how much pressure of the wind you can apply here before this goes back to something straight. That was the initial, feedback that we started to try to understand. And then we moved on. We experimented different patterns where we basically have a more complex pattern here, generating a more double curved surface, try to make it a bit more stiffer. And we also played a bit with the welding line. So like here, we have a single layer welding line, and we also change a bit in diameter of this. So we try to achieve slightly different effect according to the diameter. We're going to see that later also in the bigger mock-ups. This is basically how the structure is generally delivered on site. So you start to see some of the components here. So we have, of course, a rigid skeleton that you can see here. That is basically the skeleton of the pavilions. And we attach to that the building skin, basically. So like we're done with these interesting smart materials, able to integrate more function in one component. And of course, here you see the pneumatic elements. So we have blowers able to achieve the set point in pressure that we need for our pavilions. This is again the skeleton installed. So as I mentioned, we have basically a basement here, able to provide also the structural stability. We can also fix that down to the ground here if necessary. Then we have the cantilevered column, and then we have here the support for the components on top. And these are the different components that we tested. So here we move to the 1-to-1 scale mocap. And we were experimenting with different diameters. So we started with a very small diameter, trying to understand the resistance and the behavior. And we realized that the bigger is the diameter, the better it is for the structural performance. You have more force when you need to basically lift your element here. You also have more resistance in case of wind. So we decided to increase the diameter. So you can see that this diameter here is much bigger. And we achieved a much more stable element here. Here you see the cantilevered effect. So how different is this shape with this shape, basically, or basically was bending in a pretty sharp way. So this is the very first component that we installed. You can also see some interesting features in the pattern. So here you see the welding lines. So one is here. One is here, one is there, one is there. And you can see that basically the top welding lines are here, and the bottom welding line are basically here and there and there. And this was a key element to push to be able to achieve two chambers. So we have one chamber here at the top and one chamber here at the bottom. And playing with the pressure in the two chambers, we were really able to control the movement and to achieve a certain deflection, which is what we achieved. So here you see a bit in more detail what I was trying to explain. So we have a welding line here. You can see that here and there and there and there, there. And then we have another welding line, which is here, which is here, which is here, which is here. And you can see here there is an interesting pattern, which is this one. And this is the result of insection, of having two chambers which are basically interacting to achieve a certain movement. And when the pavilion is totally deflated, it's basically something like this. So you see all the wrinkles, because of course there is no air inside. Also the components are generally installed in this deflated way. And then as soon as you start to inflate, then you achieve the interesting result that we really wanted to see. And the idea, as I mentioned, is really to have something like this able to protect you from the sun. So when you have the sun coming in one direction, you can even make that a bit closer. If you want something a bit more protected from the sun or from the rain, and then when it rains, they close like in a very hermetic way, and they protect you also from the weather. As I mentioned, all the pumping system is down here, and then the tubes, they basically go up here and they come back here, and they are connected then to the different actuators. So here you see basically the quality of the interior. So this is not a render, this is actually a real picture. And you can see here that you have, as in the initial idea, you have your walking stations here, you have the skin protecting you. This was, of course, an indoor exhibition, so there was no need to protect you from the sun, but we started to test this indoor to keep it simple. And here you see also the lighting with the lights at the center, projecting then the lights down in this way. Again, some details about...
Paolo, 3 minutes left.
Perfect, we are perfectly on time. Here you see the final details, and here the 2 positions for the pavilion. So this is the fully closed. Here you see the pneumatic system connected into the components, and the components, as I mentioned, are gonna open. And these are all the different positions that we used when we tested the pavilion. And as a result here, we can see some key conclusions. So, well, we experimented how soft robotics can be used in adaptable structures. And basically, this pavilion opens new opportunities and scenarios to integrate multiple functions into one integrated system. Is also a pretty cost-effective way to move building components. Pneumatic systems are generally pretty cheap and also cost-effective, so you can move pretty big large structure without spending a fortune. You can also achieve, as you notice, innovative shapes, very original and peculiar, I would say. And then transportation and cost volumes are very limited, especially for the pneumatic skin itself. It can travel basically in a box. And then, of course, you have to be clever with the skeleton to make sure that it's something that you can disassemble as well. Generally, the components are very lightweight, like in this case with the fabric is less than 1 kilogram per square meter, which is generally something difficult to achieve with other materials. And then, of course, we started to understand the impact on the internal comfort and on the environmental impacts that you can achieve with an adaptable skin that can be adjusted and played with a clever microcontroller that can control this. Thanks again to our main sponsor, which are, as I mentioned, quite a few based in Europe. And then again, thanks for your attention. Before I finish, I just want to show you a video. Let me see if I can share my video with you. So just a second. Share. So the video should be maybe somewhere here. Okay. So I'm going to share the full screen again, and then here we are. So that is the video. You should get the sound. Hopefully, you should also get my voice at the same time. Okay, so I'm gonna stop sharing and we're back here with all of you. Thanks again for attending this session. Hopefully the Corolla Pavilion inspired some of you. It's gonna inspire some of you for your projects. Feel free to ask any question in the chat. So I'm here to answer to your question or now or at the end of the full session.
Okay, thank you very much, Paolo, and very insightful presentations, I think, and so many that we want to ask to you about the materials. And actually, there are already many questions in the chat rooms, and we will collect the questions in the end of this webinar series. Okay, but if you want to answer directly in the chat room, so you can answer it. It's
okay,
no
so
problem.
I'm gonna take my time to read them and then see you at
Okay,
the end
thank you.
of the day. Yeah.
Okay, thank you. So we are moving to the second presenters right now, and would you please to Pak Andhang? Pak Andhang is the second presenter. Okay, Dr. Andhang Trihamdani, the second presenter in this webinar series, and he graduated from the Department of Architecture, Institut Teknologi Bandung, Indonesia, and graduate Master of Engineering from Hiroshima University, Japan, and graduate from the Doctors of Engineering in Hiroshima University, Japan too, about the urban climate challenge in the growing cities of Southeast Asia. It's about the urban heat island and the global warming. And right now, Pak Andhang have work in Waikiki as a Waikiki AP as a R&D centers in Indonesia, and so many research interests. Right now, his research interest is about urban climates, passive designs, hybrid cooling, ventilation strategy, building material and technology. And today, Pak Andhang will present about the materials and technology, what he already done in Waikiki, I think. Okay, Pak Andhang. Pak Andhang,
Okay.
you hear me? Okay. Yeah, time is yours, Pak Andhang.
Okay, Pak Donny, thank you very much for the introduction. So let me share my screen first. Okay, is it visible now?
Yes,
So,
Pak Andhang.
Okay, all right. So thank you again, Pak Donny, for the introduction. And also thank you for the organizing committee for inviting me to this webinar series. The topic that I will be speaking today is about the application of aluminium products for green and healthy buildings, particularly in public housings in the hot and humid climate. And the main theme of today's seminar is adaptive material and technology. The word adaptive or adaptation can consist of the selection of construction materials and designs that can reduce damage or risk of potential hazards. Let's say, for example, the increased temperature in the future, for instance. The selection of building sites on the land that is not prone to the disaster. And another adaptation strategy is will make resilient development techniques that address the challenge of adaptation to climate change. Here, the terms sustainable public housing and resilient public housing presents an opportunity to accommodate environmental and social processes and to address the mitigation and adaptation challenge. There are already several straightforward solutions, such as reducing the energy consumption in constructions, reduce energy consumption during operations, and also to reduce the carbon footprint of the households. However, in regards to the resilient public housing, especially for the low-income class, the low-cost alternatives, feasible policies, and performance-based building regulation for dealing with the near future climate challenge must be explored. And on the other hand, the volume of housings, including new constructions and renovation in the growing countries, is adding more additional complexity. And this slide shows some midterm housing plans in ASEAN member states from Singapore, Indonesia, Thailand, Vietnam, Myanmar, and the Philippines. As shown, we can see that the demand for building continues. And in the case of housing for low-income household, the segment continues to grow. And the challenge faced by the green public housing and building industries in general is simply meeting this housing demand. And to meet this housing demand, building industries consisting of constructor, manufacturer, architects, things on how to supply affordable housing and also with a good quality and high quality. And aluminum is one of the materials that has been widely used as building components. And this material provides a light and strong properties, which can help to reduce weight, thus improve the energy efficiency. For example, aluminum has been used widely in the aircraft, bicycle, high-speed train, and many other products. And aluminum is also suitable for mass housing because it can provide precision, rapid production, and recyclability. However, we all know that the smelting of aluminum and the extrusion of aluminum profiles require large amount of energy. And this gives aluminum window, for instance, high embodied energy. Nevertheless, the good thing is aluminum is this material lives on, meaning that it can be recycled endlessly. It can be recycled again and again back to the same products or even into another form of industrial products. And the aluminum products in buildings comes in various functions. For the YKK AP, actually AP stands for aluminum products, by the way, and we are producing and manufacturing windows, doors, exterior items, for example, shading device, roof canopy, etc., as well as curtain wall for facade. And in general, there are two ways on how the end users or customers can have the aluminum window. First, by the finished good supply form. Okay, so this is how you can buy or can get the aluminum window. First is by the finished good. And finished good supply form, the complete window is processed and assembled in the factory. So all process will be done in the factory. So the window will arrive on site in a half complete form and ready to be installed. In this way, all the process are done by certified workers in our factory, and the performance is guaranteed. The second supply form is called the bar cells. In the supply form, the factory only produces the aluminum bar profile, and this bar profile will be sold to the distributor or applicator. Then basically anyone can buy the aluminum bar. So they can buy, they can process, they can assembling the aluminum window. So therefore, the fabrication method is not standardized. In this way, the window will be fabricated on site most of the time, and the method and the workers are not standardized and not certified, and therefore the performance is not guaranteed. But this kind of bar cells is widely used in the building projects for low to middle income class. So if we take a look at the condition of the aluminum products in the low to middle segments, we can find many low quality fabrication and installations. For example, here, the parts used are not standardized, and even it has been deteriorated, it has been rusted like this, even before the construction finish, meaning that the owners or the building managers should replace this before the handover, and that will give additional cost. And also in the unlike in developed countries like Singapore or Japan, in Indonesia, there is no standardization about window performance and quality. For example, the water tightness, air tightness, there is no standardization yet. And we found that window design and configuration in public housing is merely for beautification of the facade, rather than to provide optimum ventilation functions. And we think that it is important to improve the skills of the workers to avoid this. If we see the fabrication by uncertified workers, we can find gaps at the joints, and the connection is not straight, and this can lead to the air tightness, and even it can be very dangerous for the building occupants. Therefore, yeah, we think again it's important to improve the installation and installation method and skill, and to standardize the quality of the parts used, and to standardize or having regulation of window performance and quality. As a result of lack of regulation and lack of requirements, this slide shows the condition of indoor air quality related issues in buildings in Indonesia. The left-hand side chart shows the survey results conducted by Hiroshima University team, Institut Teknologi 10 November team, and other research collaborators. They surveyed the concentration of indoor air pollutants in kampung houses and apartment units in Surabaya, Jakarta, and Bandung. And as shown here, we can see that the formaldehyde and TVOC levels sometimes exceed the standards. And for your information, formaldehyde and TVOC are mainly found in the paint and adhesive materials in buildings. Furthermore, the center chart shows the opening window behavior in residential buildings in Indonesia, and also Malaysia is also included here. As shown, the frequency of occupants opening the window in public housing is higher. So only less than 20% never open the window, but most of the occupants in the public housings open the window. Yeah, so the frequency is higher than of private apartment and terrace house. The reasons for not opening windows are due to insects, security, privacy, and particularly in private apartments due to the use of air conditioner. On the other hand, we know that the common AC type used in Indonesia is the split system. And we all know the system is not bringing fresh air inside. Therefore, the indoor air is saturated and polluted. But last year, due to the pandemic, Daikin got inspiration. So they introduced a new system called Urusara. So this one is equipped with a fresh air intake like this. So basically it's like a conventional system, but with additional function to bringing fresh air inside the units. But maybe it's still not affordable for the low to middle income class. And this slide shows the survey results conducted by my colleagues, Dr. Nur Fajri Al-Fatah from Ministry of Public Works. He conducted a survey on thermal environment in 3 different apartments, which are old public apartments, new public apartments, and private apartments in Indonesia. As shown, this shows the temperature range in a day. And we can see that the best thermal environment is coming from the old public apartments. Here we can see that indoor temperature range is lower than outdoor. But in the new public apartment and private apartment for middle class, we can see the indoor temperature even higher than the outdoor thermal conditions. And this makes the thermal discomfort period, or let's say the duration where the occupants feel comfortable with the thermal environment is less than 30% in a day. And this shows that the occupants have no other choice than using air conditioning. But the work of air conditioning will become even harder because the indoor space is already very hot. And how can we reduce the energy consumption for cooling? This slide shows the survey results conducted in Hong Kong public housing in Hong Kong. And the author, the researcher, assessed several passive design techniques, such as shading device, low E-glass, and phase change materials, building insulation, and air tightness of the unit. And it is found that the air tightness plays a critical role for energy saving for cooling. Is up to 28.2%. For your information, the typical air tightness in Indonesian apartments is around 1.5 to 4 air change rate per hour. And by increasing the air tightness from 2 to 0.3 air change rate per hour, we can achieve the reduction of 28.2% energy for cooling. And how, if we convert this into like money, let's say in Indonesian rupiah, this costs around this saving costs around 1.4 million Indonesian rupiah per year. And this slide shows the effects of passive design techniques on thermal comfort in public housing in Portugal. And as shown, the natural ventilation and exterior shading is effective to improve the thermal comfort period compared to the typical buildings. Therefore, it's very important to secure maximum ventilation performance when the window or door is open, and to make sure that there is no leak when the door and window is closed. So this is related to the air tightness. And this slide shows the green building standards and energy codes in ASEAN. And most of the standards are mandatory, especially for large buildings with more than 2,000 square meters floor area. And the bottom table shows the requirements for ventilation, windows, and openings. And for the minimum area of windows and openings, basically all countries share the similar criteria, which is 5 to 10% of the floor area. But in Singapore, the opening area depends on the window wall ratio and solar coefficient. And in particular, related to air velocity, only Singapore proposed the criteria for natural ventilation. Let's say in Indonesia, the required air velocity is between 0.15 to 0.25 meter per second. So this 0.25 is the maximum required air velocity. But in Singapore, they promote the minimum indoor airspeed of 0.2 meter per second as moderate, and more than 0.6 meter per second as the best. And why indoor airspeed is critical? Because it's related to our thermal comfort. We all know that there are 4 environmental factors affecting thermal comfort. One of them is the airspeed. And ASHRAE standard 55 shows that by increasing the airspeed here, we can expand our comfort temperature range. And under natural ventilation, when the indoor airspeed increase, we can also increase our thermal comfort acceptability by up to 2.2 degrees Celsius. Even the indoor condition is relatively warm, let's say 30 or 33 degrees Celsius. But when we receive a nice and comfortable breeze, we can increase our thermal comfort acceptability up to certain levels. And why I talk about that? Because I'm currently doing some research related to windows and ventilation performance. Here, I would like to share one case study. We did experiments in ITB dormitory in Jatinangor. So we installed different window type in that building. This is the default window type. It's like a 3 top hangs, a small top hangs with louver, and this is a YKK-AP's proposal window. One is like this casement window with woven leaf, and another one is the same casement window but with waterproof louver. This one is not waterproof. And this is the results for the air temperature. We can see that the woven leaf and louver window can provide maximum ventilation at night. So it shows the lowest temperature here. So having a good air change rate or ventilation performance is beneficial to reduce the temperature at night. Therefore, the occupants will not need to turn on their air conditioner during the night by using only window. And related to the ventilation performance,
3 minutes left, Pak Andhang.
Okay, Pak Donny. We see that the louver window and bubbling window have the higher air change rate. So I still have so many slides. I will just go through fast and we can discuss later in the question and answer. And this is another case study in Tegal. We designed ventilation strategies for the building prototype there. Firstly, we study the climate condition. We want to understand where the wind's coming from. And then we assess the building configuration, and we found that this double loaded corridor with the atrium space is the best. But please take a note that the closed corridor is better than the open corridor. And then we also propose several window types by using CFD simulation here. And this is the buildings located in Tegal, and it's officially launched in February 2020. Just before the pandemic, and we apply several prototype windows there. And this, for example, this sliding window has a small ventilation hole in order to secure 24-hour ventilation. And the entrance door, it can be ventilated even when the door is closed. And this wind catcher window can maximize the vertical ventilation performance. Normally, we use the typical casement window like this. But here we put the hinge at the center so it can catch the wind from the sides. And here we have some ventilation products. You may have already know that most of the housings for middle class has this kind of configuration, but the high position window is mostly fixed window, cannot be operated, cannot be opened. And then we propose the high ventilation window, so that the upper window can be open and gives 3 to 4 times higher ventilation performance compared to the default conditions. And we also developed a safe open and close mechanism. Previously, we used this one with a loop, but there are some accident where this loop, how to say, it's dangerous for the children. So we changed into one string, loopless string like this. So we just pull the string to open and close the window. And this is we found that in Indonesia, there are so many, the air tightness is very poor. For example, for the main door, we can find a leak like here, where the light can see through, and then the coolness of the indoor space can come out due to like this. And we developed the hotel door. So at the bottom of this door, it can be open and closed automatically when the door is closed. For example, this one is when the door is closed condition, and this one is when the door is open. So under this condition, this gives the room the higher air tightness. As has been mentioned before, the air tightness can reduce energy for cooling, and it can give cost benefit for the users. And last is about the efficient use of materials. This pyramid shows the hierarchy of solid waste management. Now YKK is here, and most of the manufacturer is here. We recycle the scraps and the waste from the productions again to make a new billet like this. But the top of the pyramid is to reduce the amount of trash in the first place. So it's better to reduce the waste from the very beginning. So we are thinking about the standard size or modular size. For example, how many windows can be made by optimizing a single bar? One bar is about 5.9 meters, and typically, commonly, architects or users designed this size, 1.2 meters by 1.2 meters, and this will create the waste of 17 meters. But if we optimize the size, for example, we have L size and M size, we can reduce
1 minute,
the total
Pak
waste.
Andhang.
Okay, Pak. Thank you, Pak. So assume that an apartment tower has 400 units. There will be 400 units of windows. And by using the standard size or modular size, we can reduce the waste up to 68% and less material used. And this very possible to be used in modular constructions. But we still don't know whether the Indonesian market really needs the standard size products, or they prefer customized products more than modular size products. So if you have any opinion, please let me know. I really like to hear about that one. And last is about the cost and performance optimizations. This is our ongoing study. Therefore, I will not show the results here, but this is the idea. This is the basic model of Rusunami and Rusunawa, or in Indonesia. And we try to change the configuration of the inlet and outlet and find which configuration give us the best optimum combination in terms of temperature reduction, daylighting, and ventilation, which is air change rate here. And actually, at the moment, we are now here. Rusunawa and Rusunami is here. It's quite low, and we are thinking how to bring Rusunawa and Rusunami into, let's say, to the yellow color or green color, which can have a better performance in terms of temperature, daylighting, and air change rate. This is the last slide from me. Thank you very much for the opportunity, Pak Donny. I'll give it back to you.
Yeah, thank you very much, Pak Andhang. Yeah, very nice presentations, and we have already get many knowledge from Waikiki AP and your research right now currently. Yeah. Okay. From the participants, I will inform you again that you can ask and you can put the questions to the chat rooms, and the committee will give you the 4 best questions, comments, or opinions. So thank you once again to Pak Andhang, and the third presenters. I will let Pak Andry to have deliver the presentations, and this is the CV of Pak Andry Widyowijatnoko. Pak Andry right now is Associate Professor in Institut Teknologi Bandung, Department of Architectures, and he graduated from master degree from Institut Teknologi Bandung and PhD from RWTH Aachen, Germany, and so many experience to do the research about the bamboo and the woods, yeah, and some principles experience of Pak Andry right now is very interesting. Is about the bamboo structures as advisors of the Ani Permaculture Farms Resort Casita in Philippines, and designing bamboo constructions as a community centers in Pengotan, Bali, and have many award too. Mentions in Arcasia Award for architectures for the Great Hall OB, and Satya Lencana Karya Satya, of course, and the Bamboo Architect of the Years by Tempo Magazines 2014, and have a patent, 2 patents are already got by Pak Andry. Bamboo joint with radial compressions for tensile, space truss, and knockdown structures, and customized radial compressions. And right now, Pak Andry will talk about the materials of bamboo and timbers, I think. And for Pak Andry, are you still here, Pak Andry?
Yes.
You want to? Yeah. Okay.
Yeah.
Andry,
Yeah.
you have 20 minutes.
I'm sorry, because I just want to say that thank you very much for the invitation to talk in HABITechno. I am so sorry that I could not because now I have a final jury in the AA Bamboo Lab, AA ITB Bamboo Lab studio course, summer course. And then I could not deliver the presentation directly, so the committee will show the video for you. But if you have any question about this, I do not. You can do it in via chat, and I will answer as soon as possible. Thank you very much. Thank you.
Okay, thank you, Pak Andry. Maybe the committee will show the video.
Assalamualaikum warahmatullahi wabarakatuh. My name is Andry Widyowijatnoko from the School of Architecture, Planning and Policy Development, Institut Teknologi Bandung, Indonesia. It's been a pleasure for me to speak in HABITechno webinar series, Adaptive Materials and Technology. My presentation is about bamboo and timber construction for post-disaster building. I would like to start the presentation with introducing what is bamboo. Basically, bamboo is not a tree, but it's a giant grass. And Indonesia is one of the source of diversity in bamboo. Bamboo almost available in all over the places in Indonesia. And if we use bamboo, there are so many things that are very benefit for us. As a conclusion, bamboo is a very sustainable materials and also very versatile. And then the problem with Indonesia is there are so many earthquake, and during the past 30 days we have hundreds of earthquake, range from the scale of 2 until the 6. So that's gonna be the things that we will face now and also in the future. And if we take a look back a little bit about the result of the earthquake, this is the collapse structure in Lombok. And if you see this one, the timber and also bamboo construction survived from the earthquake, and the masonry construction was collapsed. It shows that in the face of earthquake, maybe bamboo and also timber is more permanent compared to the masonry construction. And then I would like to start my journey in providing bamboo for post-disaster construction by trying to develop this plastered bamboo construction, because almost no one in Indonesia wants to live in this kind of bamboo anymore because of the image of the social image of this building. And then when I saw this structure that have been 100 years there in Lumajang, Jawa Timur, it shows that it looks like a masonry construction, although beneath this plastering it was woven bamboo. That's why I want to provide a more permanent house in the image of Indonesian people by using bamboo. The idea was using bamboo as much as possible, and also using the lowest technology that is possible, and it can provide a common image of permanent housing. We can even use this very bad quality of bamboo because everything will be hidden behind or beneath the plaster. So it is also provide or improve the fire resistance and also control the interior thermal. The idea was trying to make an alternative of post-disaster housing delivery system in which that we can provide bamboo houses or bamboo emergency shelter, or even like semi-permanent houses for in a very quick way, and then with the gradually they can improve their houses by making plastering to become the plastered bamboo construction. And this is how the detail work. Everything was made by bamboo, even the column and also the beam. And then this is the our first prototype. Everything was done on the workshop. We have this prefabricated bamboo panel, and then with this prefabricated bamboo panel we can build this temporary bamboo house in only 1 day, and then they gradually can plaster this wall to become the permanent houses like this, and it looks like or similar like masonry construction. And there are so many projects that build also with this kind of technique. This is some of them. And then recently I was trying to improve the plastered bamboo construction, in which that it can be used for multi-stories building. That's why I combining the full column bamboo as a building frame, and using the ferro cement for covering the space between the bamboo. And I call it this one as rubaf, rumah bambu ferro cement, or bamboo ferro cement house. And this is the first prototype that I've built after the disaster in Malang, East Java recently. And this is the construction process, and this is the after almost finished, and then this is the after finish. We provide this building for this lady here. And bamboo is very well known that it can be it's yeah, almost every temporary structure use bamboo for the material, because it's very easy to it's available everywhere in Indonesia, and it's very easy to work with. We can make this kind of structure very easily only using the simple tools like machete, and then we can create this simple structure. That's why I try to develop more or simplest technology for the refugee. And after the Lombok and after the earthquake in Lombok in 2018, I found that there are so many refugee camp that is really unproperly built, and it's really uncomfort to live in this shelter. That's why probably bamboo can also have some kind of role with the very lowest technology. And this we provide a very simple uh, proposed family scale refugee tent using the simplest joint as possible, by using this plastic rope, yeah, basically with a small bamboo as a drawer. And then this tent consists of 11 pieces of bamboo with the same length. And then start from the reciprocal configuration. We make it as an A structure, and then we can cover it with tarpaulin to have a much better space inside this structure. And this is the workshop that I've done with my student in ITB. And then after this one, this is the prototyping, and then we build it on the real scale in Palu and also in Lombok. Yeah, we also trying to provide the fit tarpaulin to cover this structure. And this is the recently I built 4 pieces of this in Mamuju after the recently earthquake in 2019. And then one of the easiest way to construct also is reciprocal frame. Although bamboo is not really suitable for reciprocal frame, it is very uh, challenging to use bamboo for this kind of structural system, because it's interesting. It's very interesting. And then one, I make the workshop with the student from Nghi Polytechnic Singapore, and then we create this the same reciprocal frame using the prefabricated modules, in which we have the bigger modules and also the smaller modules. and basically we create the structure like this. We have this bigger module here, and this is also the bigger module, and we use the smaller module as interlocking elements to interlock the bigger module here. It's very fun, yeah, to work with students. Some of the students never been worked with bamboo before. I think almost all of the students have never been worked with bamboo before, and they are creating this very simple structure in a workshop. Yeah, basically we built like this, so we put the smaller one to be weaved. Yeah, like it's a kind of weaving system using full column bamboo. Yeah. Yeah, and then this is the final result of the structure. We built this one in I think 3 times, and then I make also the workshop in Kebun Bangsa in Kuala Lumpur to teach the architect there to make their greenhouses using the conventional one and also the modular one. And then I create also it's quite of similar reciprocal frame, but using different types of construction system. And then to make a bigger structure, I make an improvement. Instead of using this reciprocal frame with a bigger bamboo, I can use the same space inside with the smaller bamboo, but using this vector active structure. And then after the earthquake in Lombok, I asked the student to get there to teach the people there to build a very simple communal shelter there, so it will be much better space inside this shelter. Yeah, and then I go with also with student to create a bigger one using the simplest joinery system here, and then we built this one. It's also in a bigger scale. Yeah, and in here, although we built a quite bigger structure, we didn't use any scaffolding for these purposes, and everything has been done one by one like this, connecting and using the simplest joint as possible. And this is the final result of the communal shelter there, and this has been used for many activity there after the earthquake. And then I built also the same community shelter in Palu, but then after the earthquake in Lombok, one of the structure was collapsed. It was a mosque, Anur Mosque in Lombok Utara in the North Lombok, and then because of that earthquake, the aids from the provincial government and also the people of Aceh came to Lombok Island, and also my team, the ITB team, and then with the financial support from this people of Aceh, I created the design and also built the Anur Mosque using the bamboo. And this is the evolution of the reciprocal frame structure from previously I using the principle of Leonardo da Vinci bridge, and then change it, improving into a factor active structure, and then in the end I try to make the improvement combining these two systems, combining factor active and bending active structure to build this mosque in Aceh. And yeah, this is my team here with my student and also with people of Aceh and also Bamboo Boss. And the concept of the form is trying to adopt this shape, the Bali Lumbung or granary in Lombok Island. and this is the design of the structure. And then after that, we're trying to build the mosque one by one. Everything should be done, if possible, in on the floor, and then lift a little bit up here, and then connected one to the other, and we create the very beautiful structure that now become the new tourist destination in Lombok. And this is the final result of the Lombok. So far, we still need to finish this calligraph on the face of the mosque. And then sometimes bamboo is not enough because of the very big winds, and also the quality is also very weak. The quality of the bamboo is very weak. When I built this shelter, it collapsed because a lot of kids also climbing this structure, because it's going to be like the playing ground for them. And then I changed it into timber construction. Now I made it like this. Yeah, it's also one of the simplest joinery that we can build. I even can go up and feel the sturdy of the structure. And this is the final result. And after that, 4 of my master students stay there and build the other one with 2 worker there, local worker, and they can build the whole structure from the beginning less than for 5 hours. Yeah, and this is the final result of the structure, and it has been used for so many activity also in another camp area, refugee camp area. And yeah, and I built also the same in Mamuju in the 2019 after the earthquake there. So, and I also trying to provide the rukaf or rumah kayu versemen is quite similar with rumah bambu versemen. It is also combining the timber and also versemen house to provide an alternative of the house. And we built this module here in Palu, and then we traveled by the car. We already put this chicken wire, and then on the field they built the very simple um, foundation. And then after this the structure came from Palu, and then it was being built by the locals. And then we have, and then make a plastering in between the timber, and then we have this construction as an alternative of timber construction and ferro cement. And not only that, we built also another building with timber, because of it's also with the help of the government of Aceh and also the people of Aceh. And this is the structure. I use the lattice folding structure, so it's become, I think, the biggest mosque in Palu right now, with a span of 20 to 20 meters. Yeah. Yeah, as you can see here, this is a huge structure and made everything by manually. You can see the scale of the people here with the structure, and this is the biggest laminated timber with a dimension of 60 centimeters and 9 centimeters in the thickness. And the weight of this main beam, sorry, this is the main beam. The weight of this main beam is approximately more than 1 tons. So it's very, very heavy, and everything was done manually. Yeah, as you can see here, that this is the whole structure. Basically, the structures was combining the lattice system, and also to make it more stronger, I use it a folding form also here, because there will be a lot of force in this direction. I put the very strong pedestal made of concrete, and also in the entrance here I use this structure made of steel structure. So this is the final result of the building, and you can see the inner part is very beautiful structure with the lattice configuration. And yeah, this is during the sharing session after the opening ceremony. Yeah, this is the final result of the timber mosque from the outside. And thank you very much for your attention. uh, Hope to see you again soon. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Pak Andry, for the presentations and very, very insightful presentations. And I think we already have completely presenters from the futures materials to the nature material. From Paolo, that the things and have research about the futures materials, and the middles materials from Pak Andhang, and we got in the end of the sessions natural materials. It's about bamboo and the timber. So it's very, very, very completely presentations about the materials and the adaptive technology and the materials. So we are going to move to the questions and answers right now. I will show you the, let me to share the, sorry. Let me to share the screens that I will show you the questions. And because of the times, I just put some, so you can see my presentations?
Yes, we can.
It is actually the collections of the questions from the participants. So actually so many questions in here to Pak Andhang, to Paolo, to Pak Andry, and so on. So I will first questions to Paolo. And yeah. I just choose one or two questions because of the many questions in here. So I think I'm afraid that we don't have times to answer all the questions. So Paolo, there is a questions.
Excellent. I can see them.
You can answer. Yeah, you can answer upon the questions. But the important thing that I choose the questions is from Pak Robi. As we know that pneumatic system will affect to how erect this system. If it is implemented for the wide span, this one is the question. Important things for the wide spans. Can you illustrate how we completely build at the huge buildings of stadium for the examples? So what do you think about these ones?
Yeah, so basically, well, thanks for the very interesting question. Well, we use already some pneumatic structures in big facilities like stadiums as well. Like ETFE claddings are already quite popular. So somehow for those facilities, we know that having a pneumatic system with a pneumatic control is doable. However, it's a big jump to go from a static system into a dynamic system where you actually control things. There are some pilot projects that are already working. I think in this case, the very big challenge is to adapt the concept into something that is going to be exposed to the weather, basically to wind, snow, solar radiation, and a few other weather conditions. So in terms of going bigger, the key point is really to go for a bigger, you have a couple of options. One is to go for bigger diameter, so the structure has to become bigger in size. So you increase the size of the tubes and the pneumatic chambers. And we have some experience about that, for example, for envelopes for research centers with these protecting shelters for equipment, they open and close at night when they look at the stars. That is doable, but is a massive device. So let's say we're talking about a diameter of maybe 1 meter or 2 meters. So we're talking about something pretty big. You can change the fabric, go for a heavier type of fabric, which is also pretty durable. For example, boats, inflatable boats are generally based on coated fabrics, which are very strong and durable because they need to provide a pretty safe inflatable boat for your adventures at sea. So in that case, of course, you can use that material in these applications. Generally, they are pretty heavy and they are very expensive in terms of the price per square meter and the manufacturing cost. So of course, it's not always easy. And then the other thing is about increasing the pressure. So you can increase the pressure up to a very high pressure to withstand and resist the wind. The only problem of that, at a certain point, you're gonna break the fabric. So you need a fabric strong enough. And there are also other considerations to take. That generally for public buildings, you don't like to use very high pressure because an explosion is not very welcome in busy public spaces. So like ETFE roofs, sincerity beams, everything is working at pretty low pressure because you don't want to have the sound of an explosion in a public building. So you have to be pretty careful in mixing these different strategies and to achieve something that can work for a specific project. But those are the key strategies, let's say, to adopt if you want to move from this small object to something bigger.
Okay, I think that your another question is about the environment. So you think that your material is environmentally good or
good? Okay, yeah, that's another tricky question. For example, with some membranes, the material is quite good. Like ETFE has pretty high embodied energy, but also can be recycled multiple times. So with that fabric, we have quite a good experience. Otherwise, with other fabrics like polyester coated with polyurethane or PVC, you have the problem having multiple materials in the same material, in the same fabric. So at that point, you struggle to separate them at the end of the life. With PVC, there are some examples of successful strategies, but not with all the other materials. So the other strategy in that case is to minimize the amount of material. So to go for the very efficient solution that minimize the amount of kilogram per square meter of material. So at that point, even with a pretty bad material, if it's used in very small quantities, you can still achieve a decent, let's say, balance, for a pretty large building. And that is why they are pretty popular in large infrastructures like stadiums or sport facilities, because the environmental impacts per square meter are still acceptable at the moment. Of course, we are waiting for maybe some more naturally friendly coatings or fibers, of course, that those are going to solve the problem from the beginning.
Okay, what about the durability about the materials? How long is that your material is durable?
Yeah, in terms of durability, the first thing is really to understand how long your project has to last. I think for normal buildings, you generally start with ambition to have something that is going to last forever or for a very long amount of time. And because of that decision, you go for certain decision in terms of treatments, materials, and so on, installation procedures. With fabrics and temporary structure, you generally go for a very short amount of time. So you, for example, you save a lot of embodied energy and cost in the foundation. For example, you try to minimize unnecessary cost. But the price of that is that you have to be very careful about the expected lifespan. For example, the Corolla Pavilion was something that was designed for 6 months of exhibition. I think with a normal maintenance, you can probably extend that up to 5 years. But that's it. Those components, those materials are not designed for something for a long life. So you have to be very careful that when you
take into account the embodied energy, you have to divide that for only 5 years. So that is why it's so crucial to have a very lightweight and efficient systems.
Okay, thank you.
For other systems, we can extend that a bit longer. Fabrics can probably reach 20 years in case of polyester PVC. In case of ETFE, we stretch that even longer for 30, 40 years. So at that point, you have all the benefits of having a longer lifespan. But we never design for a very long period. So nothing goes beyond, I would say, 40 years, just because it is not really intrinsic in the material performance to last for such a long period. So yeah, that is, let's say, the business of temporary structure. They have to be temporary and they have to be designed for a specific lifespan.
Okay, another question is about the systems that you built in your structures, and I think it is a very interesting about the technology. And there is a question from Ariel from PUPR. This is the Ministry of Public Works. Can you explain in detail the algorithms you use for the control system? And
for that we use basically what we call
you use the sensor, right?
Yeah, exactly. We use the sensors to basically to get the input information. Then we use a microcontroller as a brain to elaborate that. The strategy used, so the algorithm is a PID algorithm, so basically a proportional, integrative, and derivative system that basically mix all these inputs to achieve a certain target. That is quite common in this industry, nothing very new. So you basically say, I want to achieve this pressure, and basically the microcontroller is going to open and close the valves to achieve that result and to stabilize that result with this strategy. I think in this case, the tricky thing is really how to select strategically the different inputs. I think this was a pilot project, so we didn't reach the end of this, so we are still working on that. But basically, the idea is that when you receive a certain radiation, you try to close the envelope to make sure that you don't get the direct radiation, and you can control each component one by one if you want. If you get the rain, of course, the priority is to make sure the water doesn't come inside, so we close the envelope even further, almost completely. We always have the need to open one of those to enter the pavilion, so that is basically the door. So we have a let's say a manual control for that, or let's say even a button on the software to make that happen. But basically, we can manually override all the different sensors just to achieve a certain thing. And then, yeah, with these systems, we try to minimize the need of air conditioning. I think there was another question about if it's environmental friendly or not. Of course, when you take the decision to air condition some a certain envelope, this is gonna give you cost for the entire life of the pavilion. So it's a big decision, pretty dangerous, because you don't know how much energy is going to be used. You know, it could be a lot. So the strategy to do that is to try to avoid as much as possible the need of this air conditioning. And the strategies are protect you from the radiation, so you don't have the direct radiation, increase the ventilation when possible. Those are the two key targets that we have in mind. But there are certain environmental conditions where even if you open and close your envelope, you will not feel in a decent comfort inside. So at that point, of course, you need to have a plan B, and the plan B, unfortunately, sometimes is the air conditioning. But at least you minimize the use of air conditioning to the very limit to the very minimum of that. And then, yeah, you have two options here: is that or you don't use the pavilion, so you say, sorry, it's going to be closed because it's too hot, or the other thing is, sorry, I need to use energy to make sure that the environment is decent. And of course, you are in between these two options. Sometimes you can just, close the pavilion. Sometimes you need to use that, and you need a plan B ready as soon as it's only used for for managing the peaks, basically, of the weather conditions.
Okay. Yeah. Thank you, Paolo.
Yeah, you're welcome.
And we are moving to the Pak Andhang's questions, right? Right now, actually there is 3 questions that I chose from Yaseri to Pak Andhang's. Are the recycled aluminum products of the same quality as the previous aluminum, especially regarding indoor air quality? And in the recycle process, how much does it cost to recycle? To Pak Andhang? Still here?
Yes, thank you, Pak Donny.
Yeah, Pak Andhang. This is about the aluminum recycled aluminum product and not recycling aluminum products. So what about this ones?
The quality is exactly the same, just like the new aluminum from the fresh billet, from the fresh, let's say the fresh raw materials.
That's raw, yeah, okay.
Yeah, and for the recycling process, how much does it cost to recycle? It's actually just like a business as usual, no additional cost. It's rather we receive from others outside or even from within our factory. We recycled, and it's just like no additional cost. It's just like burn the aluminum back to the the aluminum alloy burner, something like that.
Okay, you mean that recycle process is environmentally good, yeah?
Yes, in some extent, yes.
Okay, so we are moving to the next questions because Ari already have a question to Pak Paolo. So we are moving to Pak Agus Dwi. Have a questions. Pak Andhang, in the tropical country like Indonesia, high rainfall is a challenge for facade technology. How is the drainage systems on YKK aluminum facade system to overcome the challenge? It's about the high rainfalls to overcome the rainfalls.
Yeah, regarding
with the aluminum materials. Yeah.
I would like to separate between like the finished good, like I explained in my presentation, there are finished good products and bar sales products. So I will just speaking in case of the finished good. For the finished good, it is made in the factory, and all the products in the factory have been tested. For example, we test air tightness, water tightness, because we have the testing center in our factory. So we test the water leakage. And yeah, in regards to the water, we designed the drainage systems. So no worries of water leaking from outside to inside. If the installation is good and all the procedure is followed carefully by the installer. So,
okay, thank you. So we are moving to Pak Andry questions. Pak Andry from there is 2 questions to Pak Andry from Pak Robi and Jano. From Pak Robi, how can we make society sure that bamboo can be used for main structure for constructions? According to the durability, hopefully make it society do not see again the bamboo constructions only for non-permanently built. Do you have the programs for strengthens willing for society in order to be used, to be issued by government based on bamboo cultivation and construction usage? Pak Andry?
Okay, first of all, I would like to say sorry because my cell phone is too hot because and then it needs to be shut down, and then I use this computer and I cannot open the camera. Yeah, thank you for the question. So the idea of making the society wants to use the bamboo, basically trying to use bamboo properly. First, we have to use the preserved bamboo. And then as an architect, we need to know the principle of preservation by design. And if we do this, and then the next step would be designing the example for the people that with bamboo we can create a beautiful and also durable bamboo for an example for the people, so they will use it. As a case, I think this is also answering the last question here. Yeah.
Okay.
And I mean the last question from Pak Robbie. So the idea is how to make sure that people wants to accept bamboo is trying to make an example. It was done in Colombia by architect Simon Velez when he created so many beautiful structure, many beautiful building, and then because of that, people wants to use bamboo for their houses. So I would like also to thanks to many bamboo architect also in Indonesia like Evan, Widi, also Green School, yeah, and also other architect that trying to promote bamboo and make a beautiful structure out of bamboo as an example for a permanent structure. So I hope that this is gonna be like strengthening the willingness of the society to use bamboo. Yeah, that's from my side.
Okay, thank you, Pak Andry. And the next questions from Yano Kristanto. What is the treatment to avoid bamboo decay? And can we use another alternative for the joint than wearing the steel bolt?
Yeah, first we use most of the preservation that we use globally is using borax and boric acid. So the bamboo will be immersed in this borax and boric acid solution, and that was the main preservative that used widely. And then the alternative from joining using bolted joint, like traditional, we can use dowel and lashing. It was widely used also, but I'm not really sure about the durability of the joint and also about the reliable in terms of strength. So if you want to build small houses, gazebo, you can use bolted and you can use dowel and also lashing. But if you want to if you want to build a bigger structure, then rely on the bolted joint.
Okay, Pak Andry, this is the last questions from Arda.
Yeah, thank you.
Comparing to the brick walls, bamboo is better with the leaking problems in the rainy days. Also, how to prevent humidity that will decrease the quality of the bamboo structure inside the walls, that sometimes causing mildew. And about the bamboo columns, is there any rules to adjust the distance between bamboos to find the best sturdiness? So, Pak Andry?
Yeah, first the first question. I think the leaking is the matter of the roof. Yeah. So if we create the structure with bamboo, it's really needs to make sure that the roof is really in a good condition without any leaking. Because if the structure leaks, the roof leaks and then it makes the wall wet, and then it's gonna make the bamboo decay inside the plastering. So this is the disadvantage of using bamboo. Yeah, comparing with brick, of course, brick would be much durable in this case. And about the column, there's no certain rules. Everything was done up to now is basically by a kind of experimental trial and error, but and also the average of diameter, it's also really trial and error. But luckily today we have an ISO, the new ISO for bamboo for structural bamboo for structural materials. So we have the new ISO that have been released, and it's also adopted in so many countries worldwide and also in the UK. So you can see that for your consideration about this about your question. Yeah, thank you.
Okay, Pak Andry, if I heard from you that the concept of bamboo is like umbrella, so you have to protect from the environment outside. So you can explain about these ones? It's
Yeah,
like a
right.
umbrella.
Yeah, right. Yeah, it's like a right. It's like an umbrella. So to preserve the bamboo, you need three principles in design. First is big head. It means that you have like an umbrella. You have like a very big roof, and then the second is high heels. It means that you separate the bamboo from the floor. So it's because the floors create a lot of humidity. And then the third is good air ventilation. So basically that was the main principle, three main basic principle of designing bamboo in an analogy of an umbrella.
Okay, thank you very much for the all presenters and for the because we already still have maybe 2 or 3 minutes left, and I would like to ask to 3 presenters about the materials, the adaptive materials and technology in here. So, what do you think about that the material research materials in the futures? So, I want to ask to all presenters in here is about the how we can conduct or how we have to facing the material research in architecture's area. So from Paolo, would you please to answer my questions about the material research?
For us, of course, we are now in a challenging situation where, of course, our materials are very efficient, but they have indeed a very high embodied energy. So for us, the key point in future is to go for natural fibers, natural coatings that are able to, guarantee a certain durability without a long-term impact on the environment. So that is a bit the focus for us. It is not easy because, of course, we already use natural fibers in the past, like cotton or other coatings. We abandoned those in the 60s because we were not happy about the mechanical performance or the durability. So now we have to go back to the experience developed up to that point and build new knowledge on that and try to make sure that we decrease the environmental impacts of our fabrics. And that is the priority for us. At the moment, I have to say there are almost no natural fabrics on the market for structural long-term applications, which is a pity, I have to say, but it is because we come from a period where we had very limited options, but in future we should move in that direction. And then, of course, our plus is that we really use only a small fraction of material per square meter. So that is probably the winning part of using lightweight membrane structures, and that is what we should continue to do. So design in an efficient way, minimize the use of material. In that way, we cut half of the problem at the start without wasting material.
So I can have some red line in your opinions is about the light constructions or light materials and going back to the nature. That's your comments about the for the futures materials research. So what about you, Pak Andhang, about the materials in the futures?
More or less the same with Paolo, but yes, nature. But we have also deal with the increasing demands of housing. Therefore, the new materials should be able to be produced in a massive production, for instance, and rapid production, because we are targeting a lean construction where we want to finish a building in a short period of time. And also, we need to be very concerned in terms of the energy, not only the operational energy, but also how do we extract or produce that materials, which is embodied energy.
That's a good one. Okay, so from Paolo, we have lightweight and going back to the natures, and from Pak Andhang, we got some comments about the new materials is about the embodied energy in the materials and the mass productions. That's a good point. And I want to know from Pak Andry.
Yeah,
about
yeah, bamboo basically is a grass, yeah, and it's really going really fast. It's a renewable resource, but since that also that kind of characteristic is also create a lot of challenge in how to use this bamboo for building materials. Standardization is one of the biggest challenge, yeah. There is no standard I mean, there is no such a very strict standard in bamboo construction. So basically, it's trying to make a standardization in the bamboo construction. It's one of the biggest challenge. It's also how to fit with other materials like aluminium from Andhang, and also maybe combining the structure, the advanced structure like what Paolo did. So it's really a very interesting research on how to make the standardization also in bamboo to be compatible in so many kind of possible structure. And also about the durability, yeah, you cannot compare the durability bamboo with other materials, yeah, because it grows very fast, only 3 years, and then you need to really think of the research about how we can apply to the bamboo with less environmental impact, but then increase the durability of the bamboo. That maybe it won't last forever, but at least it lengthen the surface of bamboo as natural materials. I think that's for my side. Thank you.
Okay, thank you very much, Pak Andry. So from Pak Andry, we got some words that very important to know is about the standardizations. Yeah, standardizations material is very important to us to have a research about that ones, because we know that we lack of the standardizations in especially in Indonesia for the new material. So we are going back to the nature materials, lightweight materials, and we have to calculate the embodied energies of the materials and the mass materials, and the last one is how we can standardize that materials. So that's what we talk about this evenings. So I would like to just actually I already conclude and about the adaptive technology and the materials in these webinars. So in the end of these sessions, I would like to Paolo to choose two best questions, and let Pak Andhang to choose two best question as well. So Paolo, which ones is the best questions according to you?
Yeah, I think that Yano Cristanto was very active in the chat, so my prize is gonna go to him.
Okay.
Yeah.
And the other ones?
So yeah.
You have to choose two. You have to choose
two.
two.
Good.
Yeah.
So that one was let me say Karina, a student.
Karina
kindly asked about the environmental aspects of air conditioning and so on. So Karina,
okay,
the second one. Yeah.
Okay, thank you very much, Paolo. So you already choose two. So the committee, would you please to write it down? Karina and Yananto. Yeah.
Yano Cristanto.
Oh, Yano Cristanto. Okay. Thank you very much. And Pak Andhang, would you please to choose two best questions?
For me, maybe one is Pak Robi. He asked two questions, so he deserves to get one book. And another one, I haven't answered the question, but actually I answered the question in the chat. It's for my beloved Bu Lili.
Okay, thank you very much. So Pak Andhang already chose the two best questions. Pak Robi Dwi Juliarto.
Thank you very much. Thank you
very much, Pak Andhang.
And you cannot give the best question to the committee. Supposed to be other question.
All right.
Okay, this is the end of these sessions of this evening's webinars in Indonesia. So I would like to give the time to the host, Pak Divya. Thank you very much.
Thank you.
Thank you.
Thank you, Pak Donny, and all speakers. Paolo, Beccarelli, Pak Andhang, and also Pak Andry. Okay, it was a very interesting discussion that just opened our eyes widely on the future of adaptive material and technology. All participants, finally, we are coming to the end of this today's webinar. Now I invite you all to open your camera and show your smile because we are going to have a photo session with the speakers after this. Okay, Pak Fauzan, can you share my screen, the screen, please? Okay, next. Okay, please open your camera. I will make an announcement about HABITechno5 seminar. Next, please. Okay, you can go basically to the HABITechno.id. Is it the announcement for extended abstract submission? Deadline is 1st of September 2021, and then e-certificate is available upon request. You can register in the chat box. You can have that link. And then the 4th webinar series will be held on Saturday, 18th of September 2021. The topic is Sustainable Design Strategy. And further information about HABITechno5, please visit our website at HABITechno.id. And then this is some of important dates. And also you can see about the registration fee. We have like a early bird price, and all the info you can get from the website. Okay, next please. Okay, I just want to see you on the next webinar series. And also Pak Adit, can you, and Pak Fauzan first, can you off the screen please? And make it into gallery so we can have a photo session. Okay, Mr. Adit, would you please direct the photo session?
All right. There are 4 pages of the participants, so it will be 4 take, and I'm going to take the first one. Counting down, 1, 2, 3. Okay, second page. Counting down, 1, 2, 3. Okay, the third page. Okay, 1, 2, 3. And then the last one.
Dia sambil diumumkan ini apa? Penerimaan itu.
It's done.
Kapan
penerimaan apa, Pak?
Penerimaan extended abstraknya yang terakhir.
So we have kapan? Just announced that 1st of September, Pak.
Itu pemasukan kan?
Okay, you can go basically to the HABITechno.id after this, so check the important dates there.
Yeah, thank you.
All right.
Check.
Okay. I think that's all. As the master of ceremony today, I thank you all for your enthusiasm and see you on the next webinar series. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much, everyone.
Thank you.
Thank you. Bye bye.
Bye-bye.
Thank you, everyone.
Thank you, Paolo.
Bye.
Thank you to everyone.
Sorry, Pak Yuswadi.
Ada Pak Yus ya? Ada Pak Yus loh. Apa kabar Pak Yus?
Thank you, Pak Dr. Paolo.
Ya, thank you, Paolo.
Pak Donny, terima kasih loh bukunya ya.
Thank you, Pak.
Thank you for gimana nih?
Ya, ada kopi-kopinya dulu nggak nih, Pak Donny?
Thank you, ditunggu bukunya Pak Donny.
Terima kasih loh Pak Donny bukunya.
Saya belum dapat.
Pak Andhang, terima kasih loh.
Ya, Pak Rocky, sama-sama.
Saya kemimpi-mimpi soalnya bukunya Pak Donny itu kemimpi-mimpi sebenarnya.
Ya, tinggal beli kali Pak.
Cuma yang diimpi-impi nggak ngerasain.
Terima kasih Pak Andang.
Setelah mimpi-mimpi seharusnya langsung bayar biar langsung dapat.
Sehat-sehat
Loh,
Bu
lah kok
Lili.
dikokon bayar.
Ya, alhamdulillah.
Terima kasih semuanya. Mohon izin. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Terima kasih, Awi.
Terima kasih Pak Andry.
Tadi untuk Mas Yano Kristianto sama Mbak Karina ya, boleh
Terima
ngirim
kasih Pak
email
Bambang
atau
Suski.
kontaknya. Panitia, boleh ke saya juga, Mangga.
Pak Dipe nanti minta tolongnya alamat kirimnya mana?
Oh iya,
Tunggu
nanti saya
dari
WhatsApp
Kak
Andang.
Mm-mm.
Sip.
Siap, nanti
Terima
saya juga di
kasih.
WhatsApp aja. Saya juga langsung kirim aja.
Kirim ke
Tenan
pemenang.
nih.
Kirim ke Malang. Ini
Oh,
masih
kirimnya
live,
ke Will.
kenapa nggak dimatiin live-nya?